Hello, today's objective is that you will represent verbally and algebraically a transformed parent graph. Objective 3.5 gave you an algebraic function, and this objective is giving us a graph. So it's the same basic skill. We're still going to be using that graphic organizer of all the transformations, except the thing that we're given at the beginning is different, and the thing that it's asking for is different. So this first example says determine the function from the graph. That means my answer is definitely going to start with f of x equals, and then we're going to fill it in piece by piece. Now the first thing we need to realize is what type of function it is, and this comes from what function family. So hopefully you can tell this looks like a sideways parabola, but it's only half of one. It has an endpoint. All these things are clues that this is a square root function. And that's just something you gotta know by looking at it. So I know that this function is gonna start by looking like something like this. Square root of x, and maybe there will be some things to fill in here. So maybe there will be an a, maybe there will be an h, and maybe there will be a k. But I know that that's the parent function. Now you should know that square root functions normally have an endpoint at 0, 0. Now in this case, if you had started at 0, 0, this would have gone left 2 and down, looks like 3. So this is left 2 and down 3 from what the parent function would have been. So the endpoint has moved in that direction. So left 2 means that h is negative 2. And if h is negative 2, then that means, I'm sure you guys remember that that means that there is a plus 2 on the inside of this function. Next thing is about k. If it's gone down 3, then that means that k is negative 3, and that means that there's a minus 3 on the outside of the function. So that's after where the square root ends. Finally, with a, we would think two things. First of all, has this been reflected? Well, no, it's still going up. A regular square root function goes up, so we know that a is positive here. And then the second thing would be if it's been vertically stretched or vertically compressed. Now visually this is hard to tell. We're not going to ask you this a lot, but it doesn't look like it has been. The easiest way to tell is that from here to here, it looks like it goes up 1 over 1, which is what a normal square root function does. So since that's just a normal square root function in terms of its change right there, that means that a is 1, positive 1, because it hasn't been reflected, so we don't need to write anything there. I'm going to rewrite this just so it looks a little bit better. Our answer here, our function, is square root of x plus 2, and then with a minus 3 at the end. If you want to know if you're right and you have a calculator with you, graph this, and you should see that exact graph. Our second example of this, same idea here. We first need to decide what kind of function this is. So since it is shaped like a V with a hard corner right there, we should know that this is an absolute value function. Which means I'm going to start with f of x is equal to something with an x in it. And again, you notice I left some spaces here, a potential space for a, for h, and for k, because I could have all three of those. So the first thing I usually look for is like kind of where the vertex is. So normally an absolute value function goes through 0, 0. That's where like the corner is. So this function doesn't go through 0, 0, it goes through 0, 5, which means it's been shifted up 5. Now that's a k change, so I know that my k is equal to 5, which means that there's a plus 5 on the outside of the absolute value. This function has not, though, been moved either left or right. Now that's what h would give us. So since this is just up, not left or right, that means that h in this case is 0. There is no change, no horizontal shift. I'm not going to write plus 0 here, although if you want to remind yourself that that's what happened, you can certainly write that. Our last thing is going to be a. Now a is difficult in terms of the vertical stretch or compression, but it's very easy in terms of the reflection. Normally an absolute value graph opens up, this absolute value graph opens down. So I know that a is negative. No matter what I end up with the actual number, it's definitely opening down instead of up, so it's been reflected. Then I would kind of do the same thing we did for square root. In order to see if it's been stretched or compressed, a normal absolute value function goes like over 1, up 1. This one seems to go over 1, down 1. So other than the fact that it's been reflected, it seems to be the same shape, not stretched or compressed at all. So our A is just -1. So my final answer after I simplify all this is going to be f of x is equal to negative absolute value of x plus 5. And that's the cleaned up version where there's no space for h. So we have started at a graph, and we have written the algebraic function and verbally talked about it as we went, and that was our objective today.